The James Webb Space Telescope, JWST, an unparalleled marvel of modern science, has taken its first steps in unraveling the mysteries of the universe in ways that no telescope before it could even dream of. Launched with the purpose of observing the faintest and most distant objects in the cosmos, it has already begun producing groundbreaking results that are forcing scientists to rethink much of what they once believed to be true. One such discovery, in particular, is shaking the foundations of our understanding of galactic evolution. This discovery involves a galaxy that is remarkably similar to our own Milky Way, yet exists just 1.9 billion years after the Big Bang, far earlier than anyone had imagined such a complex structure could emerge. To understand why this discovery is so mind-boggling, we must first look at the current models of galaxy formation. According to these models, galaxies begin as chaotic, disorganized clusters of stars. Over billions of years, these star clusters slowly merge and collide, eventually forming more structured and stable galaxies. The process is thought to be a gradual one, taking place over immense spans of time, as gravity, dark matter, and the forces of star formation work together to shape galaxies into the intricate systems we observe today. Most cosmologists agree that it takes at least a few billion years for galaxies to develop the kind of complex structures we see in the Milky Way, with its iconic spiral arms and massive central bulge. Thus, the idea of a fully formed barred spiral galaxy like the Milky Way appearing so soon after the Big Bang seemed virtually impossible. However, the discovery of the galaxy known as CEERS 2112 challenges this view in dramatic fashion. The James Webb Space Telescope, with its ability to peer back in time using infrared light, detected this galaxy located at a redshift of 3, which corresponds to an age of just 1.9 billion years after the Big Bang. This galaxy was observed to be fully formed, exhibiting the same elegant spiral structure that we find in our own Milky Way. Such a complex, well-structured galaxy should not have been able to form at such an early stage in the universe's history. This discovery forces us to ask some deeply unsettling questions. How could such a mature galaxy form in only 1.9 billion years? Is our understanding of galactic evolution fundamentally flawed? Has the universe itself been much older or more complex than we ever thought? The implications of this discovery are profound, stretching far beyond the realm of astronomy. For decades, scientists have worked within a specific framework of cosmic evolution that suggests that galaxies, like all complex structures in the universe, evolve slowly over time. The prevailing narrative goes something like this: the Big Bang occurred about 13.8 billion years ago, and for the first several hundred million years, the universe was a dark and chaotic place. Then, during the process of reionization, the universe became permeable to light, and the first stars began to form. Slowly but surely, these stars grouped together, creating the first galaxies. As time passed, these galaxies merged, grew, and eventually took on the characteristic shapes we observe today. This slow, methodical process was believed to be the backbone of galactic evolution. Yet, the JWST's observations of CEERS 2112 paint an entirely different picture. Instead of a chaotic and disordered galaxy struggling to find its form, the galaxy appears to have skipped a vast portion of the evolutionary timeline. It is already a barred spiral galaxy, a structure that, according to simulations, should require several billion years of star interactions, mergers, and gravitational dynamics to form. A barred spiral galaxy's central bar of stars forms through a process involving dynamical instabilities in the galactic disk, with stars moving in such a way that they accumulate along a central axis. This process takes an immense amount of time, often billions of years, and is typically accompanied by the gradual accumulation of dark matter, which aids in shaping the galaxy's overall structure. For this reason, scientists had long believed that it would take at least a few billion years before a galaxy could develop the kind of intricate structure found in a barred spiral galaxy. Yet here is CEERS 2112, perfectly formed and already exhibiting all the hallmarks of a mature galaxy. This creates a profound scientific puzzle. How could such a complex galaxy form in just 1.9 billion years? What are we missing in our understanding of galactic evolution? Was the timeline for the formation of galaxies too long in our current models? Could there be other factors at play that we have yet to understand? the scientific community is still grappling with these questions. Dr. Luca Constantine, a researcher at the Spanish National Research Council, is one of the scientists who played a key role in uncovering this mystery. He and his team used the James Webb Space Telescope to explore a specific region of the sky that was thought to be ideal for observing early galaxies. This region, known as the Cosmic Evolution Early Release Science Survey (SERS), offers a relatively clear view of the universe's infancy, with very few stars or galaxies in the foreground. This allows the JWST to capture the faintest and most distant objects in the universe, including those from the earliest stages of cosmic history. When SERS 2112 was first detected, it did not immediately stand out as one of the most exciting objects in the survey. There were other, more distant galaxies with higher redshifts that seemed to be of greater interest to researchers. However, as the data was analyzed, it became clear that SERS 2112 was something extraordinary. Despite its relatively low redshift of 3, indicating it was relatively young in cosmic terms, its structure was highly developed, showing clear signs of a mature barred spiral galaxy. The galaxy's size, mass, and star formation rate also pointed to a relatively young and active system. Yet its shape and organization were those of a much older galaxy. This discovery has forced scientists to rethink the fundamental processes that govern the formation of galaxies. It raises the possibility that galaxies may form and evolve much faster than previously thought. Could it be that the early universe allowed for more rapid galaxy formation? Were galaxies able to form their characteristic structures much more quickly than simulations had predicted? Or could there be factors in play that we haven't fully understood, such as the role of dark matter, magnetic fields, or unknown aspects of gravity? Some of the potential explanations being explored are nothing short of revolutionary. One possibility is that the early universe experienced a different kind of gravitational interaction that allowed galaxies to develop their structures more rapidly. Perhaps the laws of gravity were different in the early universe, enabling galaxies to form and evolve much faster than previously believed. Another theory suggests that magnetic fields, which have largely been overlooked in the past, could play a crucial role in shaping the structure of galaxies. Could it be that these magnetic fields contributed to the formation of bars and spiral arms, speeding up the evolution of galaxies? Another theory is that the early universe may have seen a much more intense process of galaxy merging than scientists had expected. Galaxies may have formed in such close proximity that they quickly collided and merged, creating complex structures much earlier in cosmic history. This would suggest that the timeline of galactic evolution may be far shorter than previously assumed. It's also possible that self-organizing processes in stellar clusters played a larger role than anticipated, allowing galaxies to naturally develop their characteristic shapes without the need for external forces or interactions. As we contemplate these new possibilities, it becomes clear that our understanding of the universe is in the midst of a major paradigm shift. The discovery of SERS 2112 has provided a glimpse into a universe that is far more complex, dynamic, and active than we ever imagined. We are now faced with the realization that the universe's history may not be the slow, gradual process that we once thought it was. Instead, it may have unfolded in ways that are far more rapid and intricate, with galaxies forming and evolving much faster than current models suggest. In many ways, this discovery opens the door to an entirely new way of thinking about the universe. It suggests that the cosmos may not be the random, chaotic place that it once seemed. Instead, there may be deeper, underlying principles that govern the formation and evolution of galaxies, principles that we have yet to fully uncover. These new ideas could lead us to a more unified understanding of the cosmos, one that integrates both the vastness of space and the intricate processes that give rise to the galaxies we see today. As the James Webb Space Telescope continues its observations, we can expect even more startling discoveries that challenge our current understanding of the universe. With each new piece of data, scientists are forced to confront the possibility that the universe is far more complex, mysterious, and beautiful than they ever imagined. The discovery of SERS 2112 is just the beginning of this exciting journey, and it may ultimately lead us to a new era of understanding, one where our place in the cosmos is viewed through a much broader and more fascinating lens. In the coming years, as researchers continue to analyze the data from JWST, we may find that the universe is not just a series of random events but a carefully orchestrated dance of matter, energy, and cosmic forces. The answers to some of the biggest questions in science, questions about the origin of the universe, the nature of dark matter, and the possibility of life elsewhere in the cosmos, may soon be within our reach. All of this, in part, is thanks to the remarkable achievements of the James Webb Space Telescope, which is opening new frontiers of knowledge and providing us with the tools to explore the deepest mysteries of the universe. Ultimately, the discovery of CEERS 2112 serves as a reminder of how much we still have to learn about the universe. It shows that our theories and models are not infallible and that science is a constantly evolving pursuit, driven by new evidence and new perspectives. The universe, it seems, is full of surprises, and we are only just beginning to scratch the surface. As we continue to explore the far reaches of space, we may discover even more galaxies like CEERS 2112, forcing us to reconsider everything we thought we knew about the history and evolution of the cosmos. The journey ahead is sure to be full of awe, wonder,